Okay, so what I want to do in this video is look at some problems that are derivative-like, but a lot of people get confused on how the derivative even is involved in these types of problems. And with this lesson, you do have to know what derivatives of certain functions are using special rules like the power rule or the product rule, for example, or like the derivatives of trigonometric functions. So the way we would look at this is it kind of looks like a definition of the derivative, right? So if I write the definition of the derivative right here, it's the limit as h approaches 0 of f of x plus h minus f of x, right? All divided by h, right? And we take the limit as h approaches 0, so it's kind of like approaching the tangent line, the slope of the tangent line at that point x, right? But we want to know it at a point, at any point, a specific point. And this point that we're looking at in this problem is at x equals pi over 3, right? And we also kind of see what the function looks like. It kind of looks like it's sine of x, right? If we plug in sine into this thing, it becomes the limit as h approaches 0 of sine x plus h minus f of x, or sine of x, all divided by h, right? And we said I want x to be pi over 3, right? So this is pi over 3, and this is pi over 3. So it kind of looks like it's matching it more and more as we go through it. So I'm going to scroll this down a little bit. We should know this value. This value is square root 3 over 2. So this is the same thing as the sine of this plus h minus square root 3 over 2, right? Should be in parentheses. So it does actually match what we're looking at. It matches what we're looking at. Right here and here are the same thing. But we don't know how to continue here, because to do this, if you remember from the last video, we had to use one of the sum rules, and that takes a long time to just commit that to memory because it's always confusing which one's first, the sine or the cosine, which one's a and which one's b. So I think it's easier just to find the function and find the derivative of that function. We found it. It's sine. We know the derivative of sine. Derivative of sine is cosine, right? From the last example. However, the only difference here is that we have to evaluate it at the point. So what we want to do is write it like this. So here, let me move a little bit this way. Derivative, let me write it here. This is the same thing as the derivative of sine x, right? Evaluated, this bar, this long line that just goes down, is just like an evaluation. Like you want to evaluate it at x equals pi over 3. So then what we want to do is find the derivative, which is cosine of x, evaluated at pi over 3, or x equals pi over 3, which is the same thing as cosine of pi over 3. And then we can just use that. Something just fell. It's fine. Cosine of pi over 3, you should know that from the unit circle, but that's just 1/2, right? So, in all, what this problem is trying to say is, can you recognize what's being the derivative of? And for this example, it is sine. You're trying to find the derivative of sine, and it looks weird because they plugged in a point for you, right? They plugged in x. What this means is that they just simply want to find the derivative of sine at pi over 3. And we can just use the rule right here. This is the important part right here. We can just jump from this here, this question. We can jump all the way from there to here, just knowing that we're looking at the sine function evaluated at pi over 3. And then we can just make this jump easily and then find our answer 1/2, right? And then this next problem here kind of looks very similar too, but it also looks kind of weird because there's like h's on some terms, h's on other terms. We are thinking, what could the function we're trying to find the derivative of, right? Because we don't really want to expand this term out. It's a lot of work. Maybe this might be a lot of work for you too, but there's a trick we can just do if we know the rules for derivative, like the power rule in this case, right? So what is that function we're trying to find? It looks like it's x to the fourth minus 2x squared, doesn't it? I think so, because the only thing that people might get confused on is, wait, this sign minus does not appear here, and this is plus and this is minus. It kind of seems like that, but remember the definition. Always remember this definition. It's x plus h minus f of x. All divided by h, and you take the limit as h approaches 0. It's a minus, right? Minus whatever this is. So this is kind of like minus this, and then I just have to change the sign, right? This is the same as the other problem. Let me go back. Let me go back here. So this is the same as rewriting as limit as h approaches 0 of the function when you add a little thing to it, h, and then you subtract this whole expression, right? And we see that this exactly matches this, and it also matches the definition of the derivative. So we can just do that. So we know f is x to the fourth minus 2x squared, so we just find the derivative of that, which is just using the power rule. It's 4x cubed minus 4x. And we're basically done here. So the key things to take from these two exercises is, if it looks like the definition of the derivative but you just don't know how, try to find the derivative, try to find the function first, right? You don't want to try simplifying it through and evaluating the limit. Sometimes it takes too long, especially in the purposes of a test where you're trying to be rushed for time. So if you find any trick, for example, like with the last example we found, let me just go to the last example, which is right here, right next to it. Ooh, there we go. We found that we can just go from here to find that the function we're looking at is sine, right? And then we can just have, and then we wanted to evaluate at pi over 3. We didn't have to go through expanding this term out, right, with the identity or anything like that. And then same with this problem, the one that we just did. Instead of expanding all the power of 4 of a thing, like using the binomial theorem or just by FOILing it out every single term, we can just find a function and quickly just find a derivative of it instead of simplifying it through. So keep that in mind when you look at problems like these.